everyone. Today's lesson is going to be an introduction to a system of equations. So we're going to get more into it later in this week, but today we're just going to have a quick intro of what a system of equations is and what the solutions represent. So let's go ahead and get started with the definition. A system of equations is a collection of two or more equations with the same set of variables. So again, we have two equations. They'll have variables, and they have matching variables, and they have the same number of variables with respect to the same number of equations. All right, so the solution is where the variable values are the variable values that make all equations true at the same time. So if there's an x and y value that makes the first equation true, that same x and y value makes the second equation true. That is a solution where they both share an x and y value generally. All right, let's go ahead and look at example number 1. Let's look at our two equations. Now the question is this a system of equations? Yes or no? And why or why not? So does it satisfy the definition? A system of equations is a collection of two or more equations. I definitely have two equations, and they have the same set of variables. The first one has x and y. The second one has an x and y. So this is a system of equations. So what about the solution? Remember, the solution is where the variable values that make both equations true at the same time. So the only place where both equations share an x and y value would be at the point of intersection in this case. So what is the solution and how do you know? So we know that the solution is the point of intersection. And what is that point of intersection? So it would be this point right there. Go ahead and highlight it on your paper to make it darker. And that point is the number 2, 4. So 2, 4. And I know this is pretty small, so make sure you write small. So the solution of the system is 2, 4 because that is where the two lines intersect. So now that we know what the solution is, we're going to answer this bottom section and we're going to verify the solution. So we have to make sure that that's a solution. Visually we can see it. But let's say we didn't have the picture, but we knew 2, 4 was the answer. So we're going to verify by substituting the answer back into both equations. It has to be true for both equations. So let's go ahead and take our first equation. Again, you'll have to write small. We're going to replace the x's for 2's and the y for a 4. So let's go ahead and put a 2 there. And then we're going to put our 4, and that's pointing in the wrong spot right there. All right, so let's go ahead and evaluate this. So 2 by itself just becomes a 2. 2 times 4 is 8. And then we have the subtraction in between, and it equals -6. We simplify the left side, we get -6. On the right side, we get -6. So this is actually true. This is a true statement. So we know that the solution works for the first equation. Now we're going to go ahead and plug it into the second equation, which is this one right here. 3x minus y equals 2. We're going to substitute the x for 2 and the y for a 4. Now we're going to go ahead and multiply. 3 times 2 is 6. That minus 4 is just minus 4. And that simplifies to 2. So 2 is equal to 2. So we know that this is also a true statement. So we verified that the solution, 2, 4, applies to both the first equation and the second equation, which makes them true. Therefore, it is a solution. So I verified my solution by plugging the solution into the system to make sure it is true for both equations. Go ahead and pause the video and write this down. We're going to go ahead and do the same thing for number 2. We're going to go ahead and see where is my solution at? Well, first of all, is this a system of equations? And the answer in this case is also yes. There's two equations. They share the same variables. So this is definitely a system of equations. Now, what is my solution and how do I know? My solution is at the point of intersection, which is at that spot right there, which is for -2. I know it's my solution because that is where the lines intersect. So I'm going to repeat the same thing I did earlier. I'm going to verify my solution. Copy down the first equation, plug in for -2 on that. All right, I'm going to simplify. That's going to give me 4 plus 4, and that equals 8. 4 plus 4 is equal to 8. So we can verify that this is true. So first equation, the point holds true. And let's go ahead and do the second one. We're going to plug in a 4 and a -2 on the x and y. We get 5 times 4 is 20. 4 times -2 is -8 or -8. And 20 minus 8 is 12, which gives me that this is the solution to the system. So both equations came out to be true. Therefore, 4,2 is my solution. And I know this because I plugged it in to make sure it works for both of them. Now, in this case, it's pretty obvious. We have the picture. We know it's a solution. But we won't always have this picture, so sometimes you'll just have the point and not the picture, so you'll want to verify if it's a solution or not without the visual. All right, now it's your turn to go ahead and do numbers 3 and 4, and I will come around and check off your work as you guys are working on this. So go ahead and good luck, and once you're done, get to work on your other assignments.